For problem number 2, the figure shows 3 layers of soil in a tube that is 100 millimeters times 100 millimeters in cross section. Water is supplied to maintain a constant head difference for 300 millimeters across the sample. The hydraulic conductivities of the soils in the direction of flow through them are shown below. Find the rate of water supply in centimeter cube per hour. So, the given values for soil ABC, the hydraulic conductivities or the permeability values is already given. So here, as you can see, area is equal to 100 millimeters times 100 millimeters. So convert this into centimeter. We have the cross-sectional area is 10 centimeter times 10 centimeters. So for the constant head, we have 300 millimeters. Convert into centimeter, we have 30 centimeter. And also for the length, we have here 450, or the total length, the HA plus HB plus HC, 450 millimeters or 45 centimeter. So now, as you can see, the given figure for problem number 2, the direction of flow is here. This figure, this, as you can see, this is what we call the series flow. Since this is series flow, we have to use for series flow, we have to use the equivalent KV, or the equivalent permeability. So since we are asked to find the flow rate, so we have here the formula first. It's equal to K A I. Now let's go back to the equivalent permeability. Here, the required values for equivalent KV is equal to H, where the total for HA plus HB plus HC over HA over permeability A plus HB over permeability B plus HC over permeability C. So now substitute the values. Since we have already the H is equal to 45 all over the HA is equal to 15. This is 15 cm. This is already converted into centimeters, over the value for permeability A, which is already given, 10 to the power of negative 2, plus the 15 also, since HA plus HB plus HC is equal. 15 over 3 times 10 to the power of negative 3, the permeability B, plus 15 over 4.9 times 10 to the power of negative 4, the permeability C. So now, simplifying this using the calculator, now we have found out that the value of equivalent permeability is equal to 0.001213 centimeter per second. So we will also look for the hydraulic gradient, which is the I. Formula for I is equal to H. H is the constant head over the length, the total length, or the seepage length. So is equal to the H is 30 over the length is 45. This is already converted into centimeter. So our I is equal to 2/3 cm. So now, since we have already got the hydraulic gradient and our equivalent equivalent permeability is equal to 0.001213 0.213 cm per second. These are, you have the values already. So now substitute in order to get the flow rate. The rate of water supply here is equal to, this is 0.001213 times 13 times the I is 2/3 times the area 10 times 10, the cross-sectional area. So our rate of water supply is 0. The result, after simplifying this using calculator, the result is 0.0809. Since this is centimeter cube per second and the required unit is the centimeter cube per hour, so we will convert this into the second into hour. So simply multiply by that by 3600 second over 1 hour. So this will cancel, then replace the hour, then and then we have our final answer. The final answer is 291.24 centimeter cube per hour. This is our final answer for problem number 2. Thank you.